Okay, here are the Module 5 notes, pages 14 and 15. We're going to crank out this whole example in one recording. So here's our example 8. We've got 13 elementary students who are asked how many calories they ate at breakfast on the day of a standardized test. And of course, you know, they're elementary students, so of course they knew how many calories they had. But just in case, we have produced this fake data and recorded it in the scatter plot. Okay, so there's our graph. We have got a correlation coefficient of 0.7838. We have got a line of best fit of 0.850x plus 135.53. Our explanatory variable, are our number of calories eaten at breakfast. And I'm going to shorthand this so you don't have to watch me write that whole thing out. The response variable is our score on that standardized test. The value of the slope, remember the slope is the number that is attached to our x variable. So our slope here is 0.85. We want to interpret the slope in the context of the data. So the slope is change in our y, or change in our response variable over change in our explanatory. So the score increases because it's a positive 0.85 by 0.85 points for every 1 calorie eaten at breakfast. And I just answered this in the wrong place, so magic of technology. And I'll fix that. There we go. What are the units of 135.53 in the regression line? That is points. Our y-intercept is the 135.53. We want to interpret that y-intercept in the context of the data. If we eat 0 calories, I guess that's not eating. If we don't eat breakfast, we would expect a 135.53 score. H, the predicted test score for a student who eats 300 calories. So we are using our equation. We got a 0.85. Our input here, those 300 calories. Remember, we always multiply first. So the 0.85 times 300 happens first. And then we add that 135.53, and we get a 390.53. So we would expect a 390. Our predicted test score is a 390. Given that the least square line is y hat equals 0.85x plus 135.53, could r have the value negative 0.7838? No. Because our slope, that 0.85 is positive. So R must be positive. Could R have the value 135.53? No. R must fall between -1 and 1. Plus R is not our y-intercept. Okay, on the basis of the regression line on average, by how many points? Sorry about the typo there. Does the test score increase with each additional 2 calories? So it was 0.85 for 1 calorie. So we're going to multiply that by 2. And so we would expect a test score increase of 1.7 points for every additional 2 calories. One observation is 95 to 30. What is its residual? So a residual is our observed value minus our predicted. We have the observed value. That's the 230. So we need the predicted. My input is 95. So my predicted value is 216.28. Hopefully you paused and attempted this, which I should have mentioned at the beginning. So we have a residual of 13.72. Keep in mind that's positive, so we know our observed value lies above that line, that linear regression line. M, we have a data point that has a residual of 0. Is that data point above, on, or below the line? The data point is on the line. Because if the residual is 0, that means the observed minus predicted is 0, so observed has to equal predicted. So here we go. Observed minus predicted equals 0. Means our observed value equals our predicted value. On the graph of the regression line, is the data point 162.80 above, on, or below the line? Well, let's see what the line predicts. I get 0.85 times my 160. So my predicted value is 271.53. So our point is above the line. Because 280 is greater than that 271.53.